Do tell me more about Veritide and your food safety technology solutions.
Well, the company was originally incorporated back in 2006. It was intellectual property that came out of Canterbury University, which is a local university here in Christchurch, New Zealand. And the scientists and researchers there had discovered a really interesting way to identify bacterial spores using fluorescent light. And they started to use that for a variety of applications, but the main one that they tried to commercialise was to see anthrax spores. At the time, that looked like it could be an interesting space in the market back around 2006. And after quite a few $1 million being spent, the investors decided to pivot to another area of research, which was looking for contamination on meat, which seemed to be a larger scale problem that the business could really grow out of. So that was how we ended up pivoting towards detecting fecal contamination on meat. It was maybe around 2012 that they started to do that. More venture capital money came in, and from that time, the business has focused almost exclusively on that particular area of scientific research, culminating now in a product that we've just launched this year, which is our handheld device for taking into meat processing plants and detecting fecal contamination on freshly slaughtered carcasses. So in a nutshell, the way that technology works is that we shine a fluorescent light at the meat carcass, and our technology is able to detect the chlorophyll in the feces. We know that if there is chlorophyll and the scanner reacts to that, it's highly likely that there's fecal contamination on the carcass. And then if there's fecal contamination, then there's a possibility, of course, that there is bacterial contamination. We're able to see very tiny amounts of chlorophyll, parts per million, and that is a vector for disease that everyone in the supply chain would much prefer not to have in the supply chain. Compared to the other methodologies now for detecting contamination in the supply chain, this is quite an advanced step forward because we can do it at line speed in real time, and it's going to be a useful tool for the primary processors in particular.
Could you walk me through the specifics of how it works?
So the nature of this technology, and it's quite binary insofar as you're scanning a carcass with the light, the fluorescent light that you're shining on the carcass, the scanner will react and it will vibrate, and there's a lighting panel that lights up to indicate that the scanner has passed across some chlorophyll. And of course that will alert the user, maybe a quality control manager who's working on the line. That will alert the manager that there's some contamination there. And historically, of course, contamination has been detected mainly visually. So there'll be inspectors on a meat processing line, and they will be there specifically looking for the contamination of the carcass, visual contamination of the carcass. Of course, one of the problems with that, especially at the speed that production goes nowadays, is that it's very hard to see all of the contamination. The benefit of our technology is that we can see both visible and invisible contamination. So there's a lot of water that's used in a meat processing plant for cleaning. What often happens is that contamination that was visual, maybe just a few metres back up the processing line, has now been watered down and diluted. An inspector can't see that, and our contamination is able to detect it, whether it's visible or invisible. And that's quite compelling for a meat processor, because it means they can trap the contaminated carcasses and clean them before they get further into the manufacturing plant or further into the supply chain.
What are the benefits of your scanning technology as compared to other food safety technologies?
Well, specifically in the meat processing industry, there's a lot of time and effort and energy has gone into the management of contamination. And the way they do that is with extensive random swabbing, testing of the carcasses with swabs, taking that swab away to a laboratory for testing and doing a cell count on it to see what the results are. But of course, the turnaround time for that is is many hours. It's not instantaneous. And that's one of the benefits of the Veritide technology, of course, is that you get an instant result. You know whether there's contamination at line speed on the spot. The amount of water that's used in steam cleaning, and in some countries they acid wash the carcasses to try and decontaminate them, and then in some countries they also put them through like a blast furnace, very high heat, to try and essentially cook everything on the outside of the animal very, very quickly to make sure that the contaminations disappear. So it's very expensive and time consuming. So the benefit for our technology is that whilst we've only developed a handheld device so far, we are looking to develop a full carcass scanner in conjunction with a very well-known robotics and engineering company here in New Zealand called Scott Technology. We are going to scan a full carcass at line speed and instantaneously be able to see where all of the contamination is. I think also from a supply chain integrity perspective, the benefit of being able to see every carcass and prove that every carcass has been decontaminated is quite powerful to the subsequent customers in the supply chain. So, for example, the Walmarts or the Tesco's or the McDonald's who are buying meat from a processor, in terms of food traceability, Veritide is right at the leading edge now of that sort of innovation.
Would you say technology for food safety is exceptionally important to the APAC region particularly, and why so?
One of the things that's exciting about the APAC region for me is that right now we've developed a solution that's, as I mentioned, the basis of it is we see chlorophyll on meat. So we've perfected how to use this technology with ruminants, with animals with a ruminant gut system. So that's sheep and beef, and we've perfected the technology on that. What we haven't managed to do yet, and this is important for the Asia Pacific region, is for pork and poultry. There's not a lot of chlorophyll in a pork and poultry diet. They don't eat a lot of plant-based foods. But we're working now on a solution for pork, which we're pretty excited about. And of course, pork and poultry are a substantial part of the diets in the Asia Pacific region, more so than beef and sheep. So we're pretty excited about that pipeline development. We're hoping to have a solution within 6 months on that. We're focused on the meat processing industry because we've perfected a technology for that space right now. But that's not to say that in a minute we couldn't develop and evolve our technology to look into other areas of food safety, whether that be detecting contamination on eggs or on fresh produce. There are ways that we can adapt the technology in the future.